Hey, I'm Noggs, and this is Noggs House. You breathe oxygen every second of the day, but here's something wild. Earth didn't always have oxygen in its air. For most of our planet's early history, the atmosphere had almost none of it. So, how did oxygen get here? The answer involves tiny bacteria, rusting oceans, the very first ice age, and one of the biggest extinctions in Earth's history. This incredible story is called the Oxygen Revolution or the Great Oxidation Event, GOE. About 2.4 to 2.5 billion years ago, Earth's atmosphere went through a huge change. Before this event, the air had almost no oxygen at all. If you traveled back in time, you couldn't breathe. The only living things back then were tiny creatures called anaerobes. These organisms didn't need oxygen. In fact, oxygen would actually hurt them. They had the whole planet to themselves. The change didn't happen overnight. It took hundreds of millions of years for oxygen to slowly build up. But once it did, it reshaped everything: the oceans, the air, the climate, and all life on Earth. The creatures responsible for this massive change were cyanobacteria, also called blue-green algae. They are microscopic, meaning too tiny to see without a microscope. Their entire body is just one single cell. Cyanobacteria first appeared between 3.4 and 2.9 billion years ago, making them some of the very earliest life forms on Earth. Cyanobacteria developed a brand new way to make food using sunlight. It's called oxygenic photosynthesis. They took in carbon dioxide and water, used sunlight for energy, and released oxygen as a leftover product. Think of each tiny cyanobacterium as a little oxygen factory. Before this, other living things could do photosynthesis too, but they didn't produce oxygen. Cyanobacteria's version was completely new and changed everything. If cyanobacteria were pumping out oxygen for millions of years, why didn't the atmosphere fill up right away? The answer is the oceans got in the way. Back then, Earth's oceans were packed with dissolved iron floating in the water. When the oxygen from cyanobacteria met that iron, they reacted and formed iron oxide, basically rust. This rust sank to the bottom of the ocean and built up in thick layers called banded iron formations, or BIFs. You can actually see these ancient layers today. They look like striped red and gray rocks, and they tell us the story of Earth's rusting oceans. The oceans worked like a giant sponge, soaking up all the oxygen before it could escape into the air. This went on for about 200 to 300 million years. Scientists call this an oxygen sink. Around 1.85 billion years ago, the iron in the oceans started running out. There wasn't enough left to soak up all the oxygen anymore. So oxygen finally began escaping into the atmosphere and levels started climbing steadily. When oxygen filled the air, it was a disaster for the anaerobic creatures that were already living there. To them, oxygen was poison. Huge numbers of anaerobic organisms died off. This is called the oxygen catastrophe, the very first mass extinction in Earth's history. The survivors had to hide in places where oxygen couldn't reach deep mud, underwater vents, and other low oxygen zones. Some of their relatives still live in those same kinds of places today. While it was terrible for anaerobes, oxygen was an incredible opportunity for new life. Some organisms evolved the ability to use oxygen to power their bodies, a process called aerobic respiration. That's exactly what we do when we breathe. Using oxygen to make energy is far more powerful than the old method. It allowed life to become much more complex and diverse. Without the oxygen catastrophe, creatures like us could never have existed. The oxygen revolution didn't just change life, it changed Earth's climate. Before the GO-E, the atmosphere had a lot of methane in it. Methane is a powerful greenhouse gas that traps heat and keeps the planet warm. When oxygen started filling the air, it reacted with methane and broke it down. Less methane meant less heat, and Earth got much colder. This triggered a massive, long-lasting ice age called the Huronian glaciation. Think about that. Tiny bacteria changed the weather of an entire planet. Life itself caused Earth's first ice age. Here's another amazing gift from the oxygen revolution. Earth got its ozone layer. When ultraviolet UV radiation from the sun hit oxygen in the upper atmosphere, it created a new molecule called ozone, O3. Ozone is very good at blocking harmful UV rays like sunscreen for the whole planet. Before the ozone layer, Earth's surface was blasted by intense UV radiation, making it nearly impossible for life to survive on land. Once the ozone layer built up, it acted as a protective shield. Life could finally begin moving from the oceans onto land, and hundreds of millions of years later, that led to plants, insects, dinosaurs, and eventually us. Here's a puzzle scientists find fascinating. Cyanobacteria were making oxygen for almost a billion years before it built up in the atmosphere. Why the huge delay? Several things were happening at once. The oceans were soaking up oxygen for hundreds of millions of years. Volcanic gases in the atmosphere were also reacting with and removing oxygen. For a very long time, oxygen was being made and absorbed at almost the same rate, so levels barely changed. Tectonic events like continents moving may have also played a role. When organic carbon gets buried underground, it can't react with oxygen and remove it from the air, allowing levels to rise. The oxygen revolution shows just how connected all of Earth's systems really are. So, what's the lasting impact of all this? Pretty much everything. About 1.05 billion years ago, something amazing happened. Cyanobacteria got absorbed inside larger cells. Instead of being digested, they stayed and became a permanent part of the bigger cell. Over time, they turned into chloroplasts, the tiny structures inside plant cells that do photosynthesis today. This process is called endosymbiosis. It's how algae got the ability to photosynthesize, and eventually how all land plants did too. Every green thing you've ever seen, every tree, every blade of grass owes its existence to cyanobacteria. Even today, cyanobacteria are still doing their thing. They're among the most important carbon fixers on Earth, pulling carbon dioxide out of the air and helping regulate our climate every single day. The oxygen revolution is one of the most powerful examples of how life can completely transform a planet. Tiny bacteria pumped oxygen into an iron-filled ocean, turned the seas rusty, triggered a mass extinction, caused an ice age, and built the ozone shield that protects us today. Every single breath you take exists because of what cyanobacteria did billions of years ago. It's an incredible reminder that even the smallest living things can change the world.